I would like to start the talk by thanking the women in data science Vancouver team for giving me an opportunity to present this talk, and for all the organizers who have been meticulously planning this event for a long time. I'm an ambassador myself, so I know the efforts involved in organizing the events, and I appreciate for pulling up a great event. And today's topic for the session is going to be introduction to Vertex AI. So Vertex AI comes from the GCP platform. So what is Vertex AI? Vertex AI is an end-to-end unified platform for managing your machine learning workflow. When I say end-to-end, it starts from creating data sets to deploying your models in production, and then managing your models in the production. So it involves an end-to-end, everything you need from made from creation of data sets to the end, deploying your models at your client environment, end-to-end, everything you require is available in a unified platform, and that is called Vertex AI. Vertex AI is an offering which comes from Google Cloud Platform. So today we will be covering some of the key features of Vertex AI. There are a lot of features, but I'll be highlighting a few of them today. And so where does Vertex AI, position itself? Is it acts as an interface between the AI solutions and the Google Cloud Platform. And so some of the, features which are available in Vertex AI are, see if you will be aware of the AutoML pipeline, so which is available in GCP for vision, for videos. So you can use Vertex AI for AutoML, or you can also use for your custom training models as well. And so if you're going to use it for AutoML, the existing suite of AutoML products which is available in GCP, which is vision, video, language, tables, forecast, and all these things. Also, you can use Vertex AI, or you can use, if you're going to see, not all the time we'll be able to use AutoMLs. Most of the times we might have to write our own custom logic. So if you're going to write your own custom training code, then the Vertex AI supports that as well. And some of the features which are there at each stage of your pipeline is for experiment tracking. You have labeled data labeling feature, you have Tensorboard, and all this available for the experiment side. And for the training side, you have Visio, which is an hyperparameter tuning tool, which is part of Vertex AI. And you have the other features as well. NAS here stands for Neural Architecture Search. See, neural architecture search ideally takes hours and hours to do, and it requires a lot of computational resource as well. And today we'll not be covering about neural architecture search, but there's something which there's also a study about how there are famous companies which uses Vertex AI's neural architecture search feature, and how they're able to bring down the computational time for few hours. And then there's matching engine. We'll not be covering again matching engine as well, but these are features you can check out later as well. So we'll be covering feature stores there. We'll be covering a bit of Vertex AI pipelines. And along with Vertex AI pipelines, I'll also touch base upon what is metadata. And so these are some of the Vertex AI components which are available currently. So if you take an ML development cycle, you start with ingestion of data set, and then you take the data set, you start doing an exploratory data analysis. And during this exploratory data analysis, you start identifying the features, and then you do feature engineering. And during feature engineering, you might identify there is a need for feature transformations. Once you have identified all the features, feature transformation, feature engineering, all this is done, then you have the training phase. And then once you finish training your model, then that's when a lot of big parts come up, like tracking your model and evaluating your model and then deploying. So Vertex AI, I mentioned it in the beginning, it's an end-to-end unified platform for doing everything right from ingestion to deployment. You have tools to guide you, throughout the process of your ML development cycle. And so some of the tools, this diagram actually highlights the tools which are available right from the start to the end. So for the start, you have something called managed data sets. And so managed data sets is one of the tools which comes. Again, Vertex AI is not a free platform, and so you have to pay for it. So I may not be able to show you the demo because it will to cost me, but then I'll go to the website page and then I'll just highlight few things so that you'll be able to understand better. Again, you have to go to the Google Cloud platform, and then creation of any project and all that is the usual process. And once you create your process, you will have to go and enable, I've already enabled Vertex AI, but you'll have to go and enable this Vertex AI API. So you have all these features which are available. Once you have enabled this Vertex AI API, then you have all these. This is the dashboard which will open up for you. So you have all these features available. So the feature which here it is saying is the managed data set. So the managed data set feature is covering three aspects. One is the ingestion, analysis, and transform. So these three parts is handled by this managed data set feature. So this managed data set is this feature here in Vertex AI. So here you can go and I won't be able to create a data set, but you can go create a data set. When you click on create, you have you can create data sets for images, tabular, text, and video. So it's so you can, once you click on image classification, then it will take you the process where you can upload your data sets. So it's suppose all types like image, or you have video, you have text, and you also have tabular. For each sections you also have the types of data under tabular which it supports as well. You can also create, it's not necessarily supervised learning all the time. If you have an unsupervised data and you want to convert it into a supervised data, then there's also this labeling task features which you can explore for labeling your data and all that. And now coming back to this data set, this is this feature mentioned in the slide, is this managed data set feature, where you can go and create data sets, and you can manage your data sets. So this is what this feature means. And so if it's going to be an unmanaged data set, you can still, if it's going to be a data set which requires labeling for, so a lot of image classification task or object detection task. For example, recently I was doing a government project for India. One of the project was, it was for, again, Google supported project. So one of the project was, there's a city called Kolkata in India. And so for that particular city, we were designing a dynamic traffic management system. And so we had to label we have to do labeling from the scratch, and we had to use Vertex AI. So we were given huge volumes of traffic data from the city of Kolkata. And we had to, we used a different tool, Sense AI for labeling, but you can also use Vertex AI for labeling. And so this labeling feature is very, very important for most of the real world cases where, it saves a lot of time. And that's about the first tool. Then you also have Vertex AI for AutoML and Vertex AI for custom code. And for tracking your models, again, you have a lot of features here. So if you see the pipelines, So pipelines, if you want to automate your entire process, you can create pipelines. And we'll be covering pipelines in detail and shortly after a few minutes. And then workbench is there where you can create new notebooks. And there will be a lot of processes which you want to do, like, and those processes you can create a new notebook and you can write those codes. And you also have training here, where you can set up hyperparameter tuning jobs, you can set up custom jobs and all that. And so these are some of the features. Metadata will be touch basing little shortly. And so these are some of the features available in Vertex AI, and we just covering few of them, not all of them. So we'll start with the first feature, which is hyperparameter optimization with Visio Optimizer. So this is one of the so Vizier Optimizer is one of the black box hyperparameter tuning technique, which comes with Vertex AI. So like any other hyperparameter optimization tool, it allows you to find the best values for your hyperparameters, and it is very easy to set up. And then you also have managed experiment tracking for faster. You get so I mean, most of you might have used weights and biases or Neptune.ai or Jovian.ai. These are tools which are outside Vizier.ai, outside Vertex AI. These are some of the tools which helps you manage your model experiments and hyperparameter tunings and all that. I think weights and biases is very famous. This is similar to weights and biases only. So you can manage your experiment tracking, and you can choose the best hyperparameter, and all of it will be available in the form of dashboards. And because there will be a lot of experiments you will be conducting, and there will be multiple people who will be conducting experiments as well. And if you have to keep track of all of it manually, then that's going to become very difficult. So it is important. There is a need for a tool which manages all of it. And so you have all the features which is available in other tools like Weights and Biases, Neptune.ai, Jovian.ai. All those features are available. For example, collaboration is one of the important features there, where you can collaborate across multiple people in a team. And so here also you have that collaboration features. Then hyperparameter, finding out the best hyperparameter tuning by hyperparameters, and tracking your model results across experiments, and all of it is available in the form of visualizations and dashboards. So there's a lot more about hyperparameter optimization, and you can check out the documentation. And there's also an inbuilt suite which comes for explainable AI. So these days, a few of the organizations, there's a very clear, few of the countries, especially Europe, there's a strong laws with regards to privacy policy. And so there's a need for all of your models, which is going to be deployed in productions, should be explainable. So you will have to say it. For Europe, I think that's the case. So explainability is becoming a very important aspect these days. So Vertex AI also has a small suite of explainable AI, which comes in built. And there are only few things which it is supporting as of now. I'll just show you. So explainability, I think you have only for AutoML image models and AutoML tabular models, and custom trained models for tabular and image data. So explainability, it's only available as of now for image and tabular data. So for NLP and all, it's not available. So the very small, it's still under development, and very small set of features are available for explainable AI here. You can check out the documentation further. And the next feature is going to be Vertex Tensorboard. Again, Tensorboard is, most of you would have used Tensorboard in your collab or in your Kaggle competitions while experiment tracking. It is very easier to visualize your loss functions, hyperparameters, and all of it in Tensorboard. And the Vertex AI Tensorboard is similar to So Vertex AI TensorBoard is similar to the normal TensorBoard, which is available in your Google Colab. You don't have to do any extra setup and things like that. You can start using it similar to Colab and Kaggle notebooks, how you use your TensorBoard. Similarly, here also you can start using Vertex TensorBoard. And it just comes with additional set of features. And the next feature we'll be discussing is about Vertex pipelines. So before we discuss Vertex pipelines, we have to cover basics of what is pipeline. What is the need for pipelines in a machine learning workflow? So if you take your ideal model development, ideal end-to-end machine learning development cycle, it starts with a group of developers first finding out the business problem, then collecting the data, then doing all the analysis. And once you do all the analysis, then the training part starts. And once you finish training it, if the process doesn't stop there, you have to deploy your model in production. So again, there is a lot of things involved here. So when you deploy your models in production, there's a lot of other problems and complexities which will come. See, the features which you have used might change, the user behavior or the features could change. So there will be problems with data drift. There could be a lot of problems which comes. So in your production, if your model is not performing well, so there should be some form of notification or alerts which has to be sent to you that your model is not performing or it's deviated from its performance is a huge deviance from the expected one. And all this, there is a need for some kind of a notification or alerts which is being sent to the users. And so this is a general process which is involved. So if you take this general pipeline, at each step, the output of output of one process is going to be an input to the other process. So if we can automate this into a reusable pipeline, and which can be used across multiple experiments and which can be shared across multiple people, then it saves a lot of development efforts. And so this Vertex pipelines is one such offering, but there are multiple other offerings available as well. If you take Vertex AI has been released only in, I am aware of Vertex AI from March 2021. That's when it started getting popular. And Google's adoption also started from March 2021. But before that also, there were similar such offerings for managing end-to-end pipelines as well. So there is a general need for maintaining pipelines for your machine learning development cycle. And that saves a lot of development work, redundant work across multiple activities as well. And so what Vertex pipeline does is it just automates your end-to-end machine learning development and work cycle. And it is also a serverless offering. Serverless offering in the sense, you only pay for what you use. So, and all your servers, integration of servers, creation of clusters, creation of all these infrastructure is handled automatically, and you don't have to deal with the creation of clusters, servers, and all that. You just have to go focus on development of your model and the main parts of your model. You don't have to focus on how to create clusters, how to allot resources, and all this part. All those things will be automatically taken care of. That is what serverless means. So Vertex pipeline right now, it supports both TFX and it also supports Kubeflow. So most of you will be aware about TFX. TFX is the productionizing. So TensorFlows TFX stands for TensorFlow Extended. You can either use kubeflow pipelines or you can use TFX. And for kubeflow pipelines, again, so this is about that. And there's one more thing which you need to discuss is there's something called metadata. So any of your model, if you take, it will be associated with a lot of artifacts. So any model, if you take, it will have a lot of other details which is associated. And most of your real world use case, it is not just one model. There will be multiple models involved. And each of the model is being used by multiple products and projects as well. So it will be a complex set of graph, and it's very, very difficult to maintain all of this information manually. So that's why there's a need for managing the metadata. And this managing of metadata is also done by Vertex AI pipelines automatically. And so it comes with a lot of additional features, which makes the end-to-end machine learning workflow very, very easier. So this is how, this is what I've been telling right now. So you have the Vertex pipelines, it encompasses all of it, right from extracting data, validating, preparing, training model, evaluating model. So all of this can be, put into a reusable pipeline. So if you take each step here for extracting data and validating data, the output of the extract data is going to be the input to the validate data. And this pipeline is going to be, can be reused across multiple projects as well. And so you have a lot of, so we have also covered about what is ML metadata. So metadata is nothing but, there's a lot of lineage or artifacts associated with the models which you're using. And all these metadata can be, tracked using Vertex AI pipelines. And you can visualize the workflow. And if you have to debug any part of it, you can zoom that particular part and you can debug it, and all of it, you can do it visually. And you can also track the inputs and outputs coming from each of the block. And so these are some of the features. And so this is how it will look like, the data set which you have created. And this is how it will be a directed acyclic graph where you can zoom at any particular part and you can see what is the input which is going and what is the output which is coming and all that. And the final feature of Vertex AI, which we are going to see today, is the Vertex feature store. And so before we discuss feature store, we have to understand, a Vertex feature store. We have to understand the concept of feature store in general, and why there is a need for, something like feature store, and what are the complexities which are involved in maintaining features. And so there are some pain points in feature management. And so if you take any particular production systems using the same set of features. So if you can take very famous use cases like Walmart, and so Walmart or any e-commerce website for that matter, they'll be using a lot of forecasting techniques. So most of these forecasting projects, they'll be forecasting multiple different things, but all of it will have a similar common set of features. So, if for each use case, if you're going to, sit and generate, extract data, extract features, do that entire developmental process over and over again, for all these multiple use cases, there's going to be a lot of redundant work. And there's also going to be a lot of discrepancies within the same unit as well. So to avoid all this process, if you can have something like feature store, where you can put all your reusable features there, then it makes it easier. So whenever you have a feature store containing all the important features, it's very easy to take the needed features and build a model, train it, and then deploy it. It's going to be, the whole process is going to be very, very easier. And that's why there's a need for something called feature store. So there are a lot of people in the market who specialize in feature store management. So there are a lot of startups whose only focus is feature store. But here, feature store is just one feature of Vertex AI, but you can find a lot of companies, organizations having feature store as providing feature stores as their main USP, or that is the main selling point for them. You can go and check out a lot of such startups are there out there in India itself. And there are other issues in feature management as well. So it is very, very so there can be discrepancies between your training data and the kind of data which you are serving at the production environment. So there could be discrepancies between training and serving data. And there's also another famous problem, which is training serving skew. And so these are some of the some of the pain points of feature management. And so some of the codes of big companies, telling what their pain points are. So one famous global finance company saying, there is no standard practice how to compute features. So different team members have different, ways of computing customer click rate. So it's very difficult to reuse across different models. So I was quoting Walmart or e-commerce industry. So this applies across multiple organizations where they have multiple use cases. And for each of the use cases, there'll be some similar features which is required across multiple use cases. And if there are multiple different teams working on it, first off, there will be a lot of manual effort which is getting wasted, developmental effort which is getting wasted, because the same thing, different people across different teams are doing it over and over again. And there is a possibility, since the same thing is done by different people, there's a possibility they could make some errors. For example, here they've highlighted customer click rate. So different people might compute, different features differently. So that would lead to a lot of discrepancies within an organization as well. So these are some of the pain points highlighted by a global finance company. Another European online travel company. Every time a data scientist needs to provide a feature for online survey, they must contact IT to see if a feature is available. And then, if the IT person will go and check back if the feature is available, and then how the feature has to be represented. There's a huge time which will be going in, in these discussions and all that. So this is another point in feature management. So from an online travel company. So popular social media, when we synthesize the features online, it is difficult to ensure it captures what the user would have actually seen online. And that is, it is difficult to select attributions from right time window. And so here, so these are some of the pain points involved in feature management. So similar to Vertex AI feature store, there are a lot of other products out there which offers feature stores, and their offering feature stores is their only focus of specialization. So Vertex AI feature stores has some of the advantages. It's reusable. It solves all the pain points of feature management. It is easy to serve, and it is easy to avoid skew here. And so one of the big problems in ML is the drift problem, the data drift problem. So what happened? What causes this? I'll come back to the slide little later. So here you have the data drift problem. This is a very symbolic representation for mentioning data drift. So in your training environment, it's going to be the green banana, but by the time you deploy it, and it's going to become yellow. And so what they actually mean here is see why you might have gathered certain features, and these certain features might have certain kind of distributions or certain kind of statistical properties at the time of creation of those features, and you would have deployed those features and the model is working fine in a production environment. There could be a probability that human beings change over a period of time. So all these user characteristics which you have built over human being characteristics or whatever it is might change over a time. I'm just taking a specific use case. And then all of a sudden, the model will start not performing well in your production. So there is this data drift problem is a very, very common problem in production. And so all this can be monitored. If your model is going to deviate a lot from the expected way of performing, then you can get a notification. You can monitor when there is a data drift, and you can also monitor when there is a training serving skew. When you will get Vertex AI, you can schedule up notifications and alerts. So whenever you have such problems, and the Vertex AI also gives some recommendations on how to handle all of this as well. And so this is about this. You will be having it in model monitoring feature. Again, feature stores, one of the biggest advantages here, as I mentioned already, is once you create a feature store where you have a set of reusable features, these features can be used across projects, across teams. And you can also serve ML features at scale with low latency. So here, one thing which I would like to highlight is there are two types of servings. One, you can serve as batch serving, and there's also one which is online serving as well. So batch serving is you make predictions beforehand, and then whenever the user requests for it, you display it. Online predictions, you make predictions at the live. So there are two ways where you can serve your models, both the batch and the online. And Vertex AI supports three ways of serving features: batch, online, and one more hybrid. I don't remember. I think it's hybrid. Yeah. Then it also helps alleviating training serving skew, where you can track and monitor whenever there's going to be a drift. You can set with the baseline performance, and if your model is deviating a lot from the baseline performance, then you can set up some notification and alerts. So that way, you will know when there is a deviation. And you can do an analysis on why there is a new deviation, what are the features which caused it, and then maybe you can work around that. And so these are some of the advantages of Vertex AI features too here. So the final feature which we are going to discuss here is the Vertex AI model monitoring, and there's also something called Vertex AI prediction. So Vertex AI prediction is available in all, whether if you build your custom model training, or if it's going to be an AutoML, or if you're going to use BigQuery ML. For all three types of training, you have the Vertex. You can serve with Vertex prediction. And this Vertex prediction tool is available for all three types of training. And So model monitoring is the same thing which I had mentioned earlier. So whenever there's a deviation from the performance, you can set up notifications and alerts, and you can also diagnose why there is a deviation. And once you have found out why there is a deviation and if there is a particular feature you want to change or something like that, you can also upgrade your model. And all of this can be set up and easily monitored using Vertex AI monitoring tool. Yeah. So we have come to the end of the session. So there are a few things which I would like to point out. So Vertex AI has got a very good documentation out there. So you can go and check out, because there's a lot of other features which I have not covered here. So I've just covered the very important features. But there are a lot more other features in Vertex AI which you can go and check out. And you can also go and check out the Vertex AI samples and GitHub repository here. And so you have community notebooks, and you also have notebooks. When you click on notebooks, you have official and community. You can click on official. So you have some examples. For example, this here is hyperparameter tuning. So you have a sample notebook which you can use. So for all these topics, you have some sample notebooks out there. So for feature stores, they have used an example for IMDb movie collection. So they'll, it's a step-by-step walkthrough of how to, for IMDb, set whether something related to movies is the use case. So these are some of the sample notebooks which are available for all of the features of Vertex AI. So if you want to get started with Vertex AI, then I would highly recommend go through the sample notebooks, which will give you an idea. And you can also go through the documentation for further queries. Yeah. So we have come to the end of the session. Then I'll open up for questions. Yeah.
Thank you, Usha, for such an informative session. I think having everything in one platform is a very big plus, especially for students like us. Usually, we all are working on different projects, and then when we try to combine them, we face merge conflicts, etc. So this is a collaborative forum. So that's like a really good point. So yeah, now we can move to Q&A. So there are multiple questions. I think we can maybe start with the most upvoted questions first. Yeah. So the first question is, there are multiple MLOps tools in the market. So how is Vertex AI better compared to those tools, or what are its major advantage? I know you covered some part of this, but maybe would you like to elaborate on it more?
Yeah, sure. There are few. Again, I think if you're going to use, if you're already a Google GCP customer, or if you're again using Google's ecosystem, especially TensorFlow. For example, before Vertex AI, I think Vertex AI was built earlier than March 2021. It was there before as well, but it started getting popular, or the usage the outside world started getting to know more about it from March 2021. And before that, it was, and very few people were using it and all that. So before that, I think TFX was predominantly used for TensorFlow, for productionizing environment. Again, TFX, if you see, it just gives you model serving and very few features. So again, for integrations for certain lot of other things, you have to use a lot of external, end-to-end production model. You have to use multiple third-party tools. And imagine you are having a workflow where we have seen the ML developmental work cycle from creation of data set, deploy model. So there's a lot of process in it. Imagine using multiple products for each of the cycle. It complicates things, and there's a lot of there could be some kind of a discrepancies arising because of using, certain third-party tools may not sit well with certain, flow or certain cycle, things like that. So pulling up multiple third-party products integrations is going to be a huge headache for the person. And if you have everything at one place, then that's a great thing. Personally, I would say Vertex AI, I've just used it for just one project. So from my experience, I would say, especially if you're going to use Google Cloud, if you're already going to be a Google Cloud customer, then Vertex AI is the best thing because it's really sits well and in the pipeline. And especially if you're using TensorFlow for your production model, again, it is very, very highly recommended compared to the other competitors. But outside of GCP and outside of TensorFlow, again, there's a lot of other factors as well. So the pricing and pricing play, I mean, decision on which product to use depends on the pricing as well. Vertex AI is not a free product. So there's a lot of money which goes into it. For example, if you take just the auto ML, for each of the requests, you have to pay a huge amount of money. So there's a lot of cost involved in it. And although it makes your work easier, there's still a lot of price. So only very, very big projects can afford it. And certain features and all, it's going to be very pricey. So there's a lot of in the decision making on which product to use. I think price is a very important factor, and how many of these features are actually relevant to you. For example, if you take hyperparameter tuning or all these things, there are other tools which are very, very good. For example, for hyperparameter tuning, for more, tracking your experiments, the go-to tool would be weights and biases. So for each of these phases, there are certain tools which are the best in the market. And so it depends on for your project, what is most important, what is very relevant. And that is something which you need to identify the kind of project it is. So for huge government projects and all that, I think this is very important. There are certain projects where you cannot afford to fail. So for example, if we have to build a dynamic traffic management system where you have to identify um, if the person is not wearing a helmet or wearing a helmet, and if he's not wearing a helmet, you have to identify the number plate of that particular person, and then automatically a notification will go. And I think for India you have something called Aadhaar number, but for United States and for Canada you'll have some kind of identification. From that identification database, automatically his address will be found, and then the bill amount will be sent to his address. This is a use case which we have. So here, these are use cases where you cannot fail. You cannot afford to fail. Imagine you're going to penalize somebody wrongly, or you are going to, if the system breaks down because of not properly managing the resources, whether memory or the number of servers which is required. If you're not able to manage it properly, and if the system breaks down, this is a government project. So the lot of people who will be immediately getting affected if this government is going to penalize the wrong people. And if the system breaks down also, that's a huge cost to the government. So there are certain projects in real world where you cannot afford to fail. Another one important use cases where you cannot afford to fail is banking. Again, there, the failures are very, very costly. So these kind of projects, you definitely have to go for some, even there's a strong need to go for certain platforms like Vertex AI. Again, if you take government projects, I think these are like multi-crore projects, which is like millions of dollar deals. So I think for these kind of projects, Vertex AI is much suited. So it again depends on the kind of projects, what is very important, and what are the things which cannot be compromised. The objectives of the project all has to be analyzed, and then the best thing has to be chosen. And so yeah, it depends from case to case and use case to case. You have to do a careful analysis of what you want, and then you have to decide which is the best product for you. But that being said, there are a lot of interesting startups which are coming up both in India and outside. which deals with MLOps, which specializes in MLOps specifically. Yeah.
Yeah, thank you for that. That answers the question. But yeah, I think it makes sense that if you're working on a big, very crucial project, then just go for the best tool which has everything in the tool rather than going for tools that are dependent on third-party products. So the next question is, how portable is the data pipeline model developed using Vertex AI? Is it possible to move the developed project to company's internal system, or it needs to be used in the Vertex AI platform?
See, you can see these are components of Vertex AI. It's not necessary that although you have features for every process in your ML developmental cycle, you have certain features. For example, first 3 steps, you have something like managed data set. But again, even in this state, it's not necessary you should use a managed data set. You can also skip this complete process without using this managed data set. You can just use whatever, if you have an internal company pipeline, you can just go ahead with it. So these are all this page contains all the features of Vertex AI, but you can decide on what you can just use 1 or 2 features of the Vertex AI. You can just use feature stores or just the model monitoring alone. And or you can integrate. I think Vertex AI has got good integrations with the other third-party systems as well. So it will sit well with your internal data pipelines as well. So most of them use it for the model monitoring, because this data drift problem, this training skewing error, these are the most common problems in production environment. So a lot of people may not necessarily use the managed data sets, because the managed data set may not sit well with the internal company. It depends from use case to use case, but it may not sit well for all kinds of use cases. And so the most common thing which generally I find a lot of people using is the model monitoring. And model monitoring, and that is the most commonly used features. And for certain bigger organization, they also use feature stores. So these are most used products from the Vertex AI. But the other things, I think it depends on your use case. If you want to use your internal company's data pipeline, then you can use Vertex AI. I think the integration with your internal pipelines is very smooth, and it works well.
Okay. There's a follow-up question to the first question. So like you talked about how to choose tools based on your use case, but what about from price point of view? Say you would just want to use a part of the pipeline. You don't want to use all the features. You just want to tune and test your models. So is that possible? Can you select and just pick those features?
Yeah, you can select and pick those features, whatever you are using for the pay. I mean, you also have something like pricing calculator, where you can also check out the pricing. And so you have the pricing here for deployment and online prediction, for batch maintenance, for each kind of usage you have, or what kind of pricing. So for AI this year, if you see, what is the pricing? This year is an hyperparameter optimization engine, right? For that, you have the pricing, and for which location you are using that, based on that, you have the pricing. So you have AI Tensorboard. AI Tensorboard also you have the pricing. So nobody will get Vertex AI Tensorboard, because your Tensorboard is a free tool available in Colab and Google. So nobody is going to use these features. So most probably you will be ending up using model monitoring. And model monitoring you can check out, because if there is this famous problem with data drift and training serving skew. And so if this is happening, then this is what is most commonly used, and you can just use this alone. You have a separate pricing for each of the features. So if you want to use Vertex AI features too, then you have. So I told you there are 3 different types of serving. One is the batch, online serving, offline storage, and also for each of these use cases, you have different pricing. So whatever feature you are using, that feature only you will be paying for it. So if you use 1 or 2, only for those 1 or 2 you're going to pay.
So that's good news for most of us. Yeah, so the next question is, nowadays the interface ML ops is easy to use. Do you think that in the close future, even non-data science folks can use this tool to perform like basic data analysis?
Yeah. Vertex AI is very, very friendly for non-data scientists because, Google platform itself has got auto ML models. So if you're going to use the Vertex AI auto ML pipeline, then the person, even without any knowledge in AI, somebody who doesn't know AI, who doesn't know programming also, they can use auto ML. So everything is a drag and drop, and setting up using parameters and creation of filling out certain forms, creating few things. You can just watch a documentation, and even without any data science knowledge, even without anything, you can work on Google AutoML. So it's going to be very, very easy things. And so this particular part, even without zero data science knowledge, you can use this part. uh, so this is the part which is available. If you're going to build your own custom training models, then definitely you require data science knowledge. And so what is the ideal scenario which I would recommend is, see, there are a lot of times in real world, particularly there are use cases like genomics, and there are use cases, certain use case, not all, certain image-based neuroscience and all. You have a lot of the studies which has already come out, but in neuroscience itself, there are certain areas which has not been explored, and genomics also does not explode widely. There are a few research happening here and there, but that's not a very common. Semiconductors, so these are very, very rare fields. So for semiconductors, if you see, you have to know, for touching any use case in semiconductors, you have to know the domain knowledge very, very well. And so if you're going to be a data scientist, not all data scientists know semiconductors, or they know the background knowledge of genomics or all these things. So these are some of the domains where the domain knowledge is very, very crucial for an effective solution to your problems. And so the one hand, you have a person who has done a PhD and who has got a lot of research publications. So that person has to sit with a data scientist to solve the problem. So that in real world, if you see, that requires a lot of time, because the multiple people across different companies coming and collaborating, that requires a lot of, you have to schedule meetings. There's a lot of time which goes spent on that. And what if there is a way where the domain experts doesn't have to depend on these data scientists? If don't have to build a complete end-to-end model, but if they have the necessary tools to quickly prototype and see, multiple experiments, and that would be great, right? That's where this AutoML thing comes, where the domain experts can quickly prototype and test out various ideas which they have. And once they understand, these are the paths which they should pursue in the longer term, then they can sit with a data scientist or a data science team to, flesh out that solution and build a complete end-to-end pipeline. But for the initial prototyping and all, these kind of AutoML tools are really helpful. And for minor experiments, again, it's not going to cost you that much. And so minor experiments, again, you get $300 free if you just create a Google account and a first-time user. It's minor experiments, not good. But if you're going to deploy it in production, then AutoML is going to cost you a lot. For each request call, you have some 0.5 or 0.25 based on the service which you use. You'll be spending somewhere close to $1 to $3 for each request. That's going to be like very, very pricey, unless until the project is very huge or some big client. It may not be recommended, but for initial prototyping, it's going to charge you very, very less. So those are situations where I would recommend AutoML usage.
Okay, yeah, I think that helps, especially for folks who are not familiar with data science technologies. So in interest of time, we'll maybe come to our last question. So are there any tools you use to supplement using Vertex AI?
Yeah, so see, the Vertex AI, the only project which I had done was an Indian government projects where I had to use Vertex AI because they were already using GCP pipeline and they want everything to be a GCP pipeline. Otherwise, the most commonly used tools are, you can use a lot of open source tools itself. So weights and biases for your personal use, it's very free. And so you can track your experiments, you can visualize it, you can also see. So weights and biases is something which I use a lot. And only if you have to use it for your company purpose, or if you're using it for your organization or something, then you may have to take up a paid account. But if you're just having for caggling or for other purposes, or doing some minor use case testing, community projects and all, I think weights and biases is a great tool. And even for an organization perspective, the pricing is very friendly as well for an enterprise perspective. So weights and biases is one of my favorite tools, and it also makes the collaboration very easier. So there's another tool which I also like is Jovian.ai. So here also you can create notebooks where you can collaborate. You can create public notebooks where you can collaborate with people, similar to what you use in Google Collab, where you can add collaborators, right? Similarly, you can create public notebooks here where you can add collaborators. So if there are going to be 3 to 4 people who are doing the project, and so all your friends might be conducting multiple experiments, they'll be using different kinds of hyperparameters, and to track all of it, you need some kind of a unified tool. Weights and biases is commonly used, and Jovian.ai is also very. So if you want to compare pricing, you can come out. Pricing comes into picture only if you want to use it for your organization across teams and stuff. If you're using for your personal projects, weights and biases is free. So I use weights and biases is my favorite tool for all the Kaggle stuff which I do, and for all the competitions which I do and all that. And outside that, it purely depends. For any enterprise project, it purely depends on the client. So for example, the client which I mentioned, it's going to be Indian government, and they've already had every pipeline, all or their other projects, other use cases, everything is in GCP. So it would be a very bad decision to use any other tool there. So it depends on the client, what ecosystem they are using, how much of money they can afford, and what kind of project use cases. These are factors which goes into deciding the. But for your own personal projects and thing, I think weights and biases is more than sufficient if you want to do Kaggle or minor use cases or small community projects and all. I think weights and biases is more than sufficient. And there are other products as well. There's one startup in India, I think it's called Saturam. They were dealing with model drifting and all that. Saturam is just one example which I'm giving, but they were dealing with model drifting. There's one more famous startup which recently got funding. It's again from India. I forgot the name, but they recently received some 2-3 million funding. They specialize in feature store. And there's one more startup where this famous AI influencer, her name is Chip Yogan. She's also a Stanford alumni, I think. She also is building an MLOps. She's one of the founding members of a startup which completely deals with MLOps. So there are a lot of startups which are coming up, particularly in India. There's a huge surge of startups which specializes in MLOps and things coming up. So hopefully things will look out good in the future. Yeah.
Thank you so much for answering our questions. I think this was a really apt topic for data science ecosystem and gave us a very new perspective to MLOps. So we will maybe now have a 10 minutes break before our next speaker session. And we'll be keeping our breakout rooms and networking rooms open in case anyone wants to use them. So I'll see you all back at 10:40.
Yeah. Take care. Bye-bye.
Thank you. Bye-bye.